Alan has an intriguing question for us. What if every human vanished from Earth? How long would artificial lights keep shining? First, let's address the obvious. Most lights wouldn't last long, as major power grids would quickly fail. Although power demand would drop, fridges, air conditioners, and lava lamps would still be running. Fossil fuel plants, which generate most of the world's electricity, need a steady fuel supply, heavily reliant on humans. As coal and oil plants shut down within hours, other power sources would struggle under the extra load, leading to a rapid series of cascading failures and a blackout of all major power grids. Nuclear reactors, on the other hand, don't need a constant fuel supply. One operator mentioned that if a reactor core settled into low power mode, it could run almost indefinitely, as a cube of uranium contains about 6 million times more energy than a similar-sized cube of coal. However, most reactors would shut down quickly due to automatic safety protocols triggered by any malfunctions, likely caused by power grid failures. Not all light sources rely on major power grids. Let's explore some off-grid options and their potential longevity. Remote communities on far-flung islands often use diesel generators, which can run until their fuel tanks are empty, ranging from days to months. Off-grid stations that don't need human-provided fuel, like geothermal plants, can run for a while without maintenance. In Iceland, the Svartsengi Island geothermal plant requires maintenance every 6 months. Without it, plants may run for years, but eventually succumb to corrosion. Wind power offers a slightly longer-lasting option, as wind turbines are designed to minimize maintenance. For example, Denmark's Gedser wind turbine, installed in the late 1950s, generated power for 11 years without maintenance. Modern turbines are typically rated for 3 years without servicing, but some may run for decades. However, eventually, their gearboxes would seize up, similar to geothermal plants. Hydropower generators can also keep running. An operator at the Hoover Dam mentioned that if everyone left, the dam could continue operating on autopilot for several years. However, without a functioning power grid, the electricity would have nowhere to go, and the dam would likely fail due to clogged intakes or mechanical issues. Battery-powered lights would fare even worse, as batteries self-discharge over time. Even those with long shelf lives typically last only a decade or two. Solar power is the most promising candidate. Off-grid solar-powered buildings, weather stations, and other infrastructure could last long. Solar-powered emergency call boxes, often found along remote roadsides, have lights that provide nightly illumination. Like wind turbines, they require minimal maintenance and can last for a long time. As long as solar panels are kept free of dust and debris, they can continue providing power for a century in optimal conditions. If we adhere strictly to artificial lighting, solar-powered lights in remote locations might be the last human light source. But there's another contender: spent nuclear fuel. While radioactivity isn't usually visible, certain materials like water or glass emit light when radioactive particles pass through them, creating Cherenkov radiation. This blue glow is seen in nuclear reactor cores and some radioactive waste products, such as cesium-137, which is mixed with glass and stored in shielded blocks. Cesium-137 has a half-life of 30 years, meaning its glow will persist for centuries, gradually fading in brightness but retaining its blue color. So, centuries from now, deep in concrete vaults, the light from our most toxic waste will continue shining. If you enjoyed this story, make sure to like this video, it really helps us out. Share it with friends who'd love to learn something new, and subscribe to the channel for more fascinating content like this. Don't forget to turn on notifications so you never miss an update. Thanks for watching, and I'll see you in the next one.